My name is Healey. I study forest dynamics. I study changes in carbon, changes in forest structure when they are disturbed, that is burned or cut down. I also study recovery, which is what we see a lot of following the eruption of Mount St. Helens. I visited it for the first time 20 years after. It was like a moonscape. A lot of it was still like a moonscape. You know, pieces of pumice on the ground, no vegetation. It has been a place of extraordinary change over the last 40 years, from really beautiful old-growth forest to a moonscape, and then back again to a lot of unbroken sort of 20-year-old forests, pretty high canopy cover, a lot of trees there now. From the fringes of the blast zone, you definitely see patterns of revegetation. They start slowly with a little bit of greening, but by the time you get to the end of the time series, it looks pretty dark green. And you see the same thing on the ground. You see maybe not a 40-year-old forest, but something that looks 30 years old. And in this part of the country, trees are pretty tall after 30 years. What we're looking at is Mount St. Helens in southwestern Washington in 1973. The snow cover is what you see as white there, right in the middle of the mountain. It's surrounded by some dark, deep reddish forests, which is basically how this MSS imagery sees older growth forest. To the east of it, we see a lot of very active timber harvest. All of those patches of blue are recent clear cuts. Just to the north of the mountain there, you see a very large clear cut. That one happens to be about 2 square miles, which is really, really large by today's standards. And then Spirit Lake, just to the northeast of the volcano, you will see that the shape of that lake will change radically after the volcano erupts. Well, in this image, I mean, if you remember that large clear cut that I pointed out, you can see that it's starting to go from that bluish cast to having more red, which indicates, recovery following harvest. And 6 years has passed, so you would definitely expect that in a very productive forest like this one. And it has been joined by a lot more clear cuts in that area too. I have looked at a lot of Landsat scenes. This is the biggest change from one image to another that I can think of. Forests and everything else, many miles to the north, were just incinerated. The blast and the heat and the ash really leveled a lot. It looks from this image like Spirit Lake just to the northeast of the volcano is not there, but it is there. It's covered in logs. And most of the water in that lake got splashed up 600 feet or more and sort of dragged all of the trees that were on that wall down. Over the 40 years since the eruption, we do see that recovery happens first in the places that didn't have, that huge blast of heat and were not covered with many, many meters of ash or mud. In '84, the first thematic mapper, Landsat, was launched. So that really changes our ability to display this kind of image in something closer to true color. So it's much more intuitive. Green means green. So from this point forward, you can sort of visualize the encroaching greenness, which indicates, the revegetating and reforesting areas after the eruption. Well, I'll also point out some of the remaining old-growth forest that you can see in that very dark patch. In the MSS imagery, that was dark red. It's just much more intuitive to spot that kind of dark green when we can display it in true color. You can see in the early 90s, clear cuts starting to pop up. So basically it looks like it's going from green to some kind of brownish color. Even as the outer edge of these clear cuts are growing and filling in, the inner edges are greening up and turning green. And by the end of the time series, they look pretty green, even though we just saw them get cut 30 years before that. So we have basically made a model that uses the imagery to predict what percent cover there is. Basically, how thick is the tree canopy here. And through the time series, you can see much of the blast zone going from red, which is 0 trees, to pretty green, which is, pretty solid tree cover. And that's really solid documentation of, the recovery of the forest in this area. You can also see, its neighboring places go from green to red in the opposite direction. Obviously, there are harvests happening, and those are taking away forest canopy at the same time that recovery is adding forest canopy in the place that was affected by the eruption. The really unique part about the Landsat record is the fact that it goes back to the 70s. I can't imagine what it would be like to describe what this volcano did without having a time series of Landsat. We've got 8 years before the eruption and 40 years after the eruption. There is no other asset in the sky that can show us what Landsat does in terms of the effect of this eruption and also the effect of recovery following the eruption. It's just amazingly lucky that Landsat was up there and in its spot in the sky to watch this whole thing unfold. Let's hear it from Landsat.